Hey everyone, welcome back to the lab. In this video, we're going to be talking about HTML template parsing benchmarks with F# and Scriban. So I've been experimenting with server-side rendering HTML templates in F# and dotnet as a potential evolution for faster, simpler UIs in Cloudseed, my F# web API boilerplate. If you don't know, Cloudseed is basically what I'm building like all my projects from. Think of it like a Next.js or something like that for F#. When I want to build something new, I just clone the repo, kill the .git, and kind of start from there. Currently it uses SvelteKit, but I've been thinking about, moving over to just server-side rendering to make this a lot faster. Anyway, Scriban, for those who don't know, that this is like a library for basically parsing templates and then filling it in with values. So kind of like what Razor Engine is, or Jinja and Django, or Mustache or Handlebars from like Ruby world or JavaScript world, things like that. Scriban is a version of that for .NET that's extremely fast. So Scriban was a top contender for templating my HTML strings, as it's popular in the C# .NET community and has a clean, performant API. It's basically the most popular one outside of Razor Engine, and Razor Engine's kind of clunky, so this seems like the best one for most people, and why I'm trying it. As I built UIs with Scriban, I noticed that there was an opportunity to cache some templates, but I wasn't sure how impactful this would be, and thus whether it would be worth doing. In some languages, the way that it builds its templates is like through a lot of like reflection and like things like that. So like Razor Engine, for instance, I would expect that to be really slow to parse things, because it's probably like building some mumbo jumbo OOP stuff inside of it. But then some of them are just like raw parsers, so it's not much, but you kind of have to try it to figure it out. So in this post, that's what we're going to try to figure out, basically, is what's the performance difference between reparsing a template on every call, so something purely functional, basically no state, or utilizing a cache template with Scriban. Okay, and we're going to start with like the executive summary, which is basically that overall cache templates are faster than reparsing templates every time by a factor of about 5 to 30%. The difference is more pronounced for smaller templates and becomes less meaningful for larger templates as rendering takes up more work. So you can imagine that parsing the template takes some amount of time to get internal state to understand like what kind of operations are in there, what kind of data is it looking for, and then the rendering time is like, hey, I'm passing the data into the parsed template and now you need to turn that thing into something. So at smaller like data sizes, the parsing is likely going to be a larger part of that render time, and that's kind of what we found here. So that said, the absolute time differences are incredibly small, like less than 1 millisecond. So both approaches, both caching and reparsing every time, will likely scale very well and often much better than other popular approaches like insert favorite JS framework here. Yeah, I haven't done like a full head-to-head like benchmark of this, but I think it would be interesting to see how fast these things go head-to-head, because a lot of these big, JS frameworks, they've got a lot of tricks in them and stuff that makes them go faster, but at the end of the day, it's still running JavaScript and is kind of constrained by whatever hardware it's on. So I'd be curious to see like in real world scenarios what the differences here. Anyway, here's the high level kind of readouts that we've got. So at 10 items, cached is faster by about 30%, but this is like 0.05 milliseconds, so like unnoticeable. For 100 items, cached is faster again at 20% at 0.1 milliseconds. 500 raw actually comes out faster, which is interesting, at 7%, but the difference is 0.2 milliseconds. So this might just be kind of like a fluke. They're only 0.1, 0.2 milliseconds different anyway. And, a lot of things of random factors could kind of cause, definitely 1 millisecond of difference. At 800 items, we see that cached is still faster, but we're now only down to 4% because the 0.2 milliseconds just isn't much of the entire runtime. And then at 1,000 items, we start to fail actually, because we hit a reflection limit, which we'll talk about later. So in the rest of this post, we're going to explore these benchmark results in greater detail. We're going to start with the benchmark setup. Then we're going to show you the detailed results for each of these. And then I'm going to show you the full benchmark code so you can kind of understand what's going on. As always, the source code is available here in the post. I'll have the full printout at the bottom, which we'll look into in this section. And then I do have this on Replit as well, because I like making these benchmarks available so people can kind of come in, critique them, change them up as well. So here's the Replit, and we'll be diving into this code later on as part of like the full source code, so you can kind of see me running it and we can kind of explain exactly what it's doing. Okay, now let's go into the benchmark setup from a high level. So I wanted to approximate a real world example for utilizing the Scriban library for HTML templating. To that end, I built a simple HTML template that would display data in a table. Each row is a string, which we pre-compute before the benchmarks. And so this is obviously a very contrived example, but this is kind of what, you'll be doing if you are building templates like this. So we just get like, our basic headers and stuff for our HTML, and then the body what we're doing is we're just creating a table, and we're using Scriban's templating language. If you've used like Handlebars containers or Svelte kit or anything like that, this will look very familiar. So what we're going to do is we're going to pass in, well, this is the template that we're going to parse, right? And then what we're going to do is we're going to say when we want to render, we're going to pass it a list of items. And then the template render work will be to take the parse template and then actually fill this out so that for every item we get a new row here. So pretty simple, a very contrived example, probably the simplest you can get, but at least we can kind of try, both the parse and render cycle. So this allows us to test the full life cycle of a template, which is closer to what I cared about for my usage. We can do the parsing here, again, turning this into something that Scriban can understand to fill out with data, and then the rendering where we're taking the compiled version of this template and actually filling in the data here so that it turns into like real HTML. So for this benchmark, I wanted to test two versions. First, we got our cached parser where we parse the template and then we just benchmark rendering with the cached parser. So we're going to save it off outside the benchmark and then we're just going to keep rendering with that to see how fast it is. Then we're going to use the raw parser where every time we call it, we're going to both parse and render the template on every call. And so here's what it looks like. This is F#. If you're not new, or if you are new to F#, this probably looks a little weird. But here's the cached parser. What we're doing is we're taking our template, which is that string we saw above, and then we're going to create this compiled template. And we do this by saying scriban.template.parse. And so this is going to do whatever Scriban needs internally. Who knows what it's doing? And we're going to have the compiled template here, which we can then use later. And what we're doing here is we're returning a function. And so basically this is creating a closure over this so that we now have this in state within the version of this that was created. So every time we call this with template props, it will re-render, but it's going to keep using the same compiled template because that's inside the instance of the function. Here's just the render function. So we're passing in props, which we pass in here, which is again just that list of items. And then we just have to do some funky stuff to make sure that the naming's correct outside the scope of this video, but you can look that up on their GitHub. It's not too hard. Okay, so that's a cached parser. It's cached again because we're holding the state here. So we're not re-parsing. And then we've got the raw parser, right? So we're going to pass in the template again, and then we're going to be able to give it props. And what it's going to do is every time it's going to do the parse and it's going to do the render. And you can see how we create this here. So we got the cached parser, test1 equals to cached parser passing in the template. And again, this is now going to return this function that we can keep calling. And then for the raw parser, we got the raw parser, we're passing in the template, and then we can keep calling this, and this is going to be curried. So think of it just like basically raw parser prop, but it's going to keep calling both of these each time. Okay, so for benchmarking, I utilize benchmark.net, a popular battle-hardened framework for running benchmarks with .NET. Highly recommend it. It's a little object-oriented, but you can pretty easily use it with F# because they're both targeting .NET. So that's the benchmark setup. Okay, now let's go into the detailed result. Okay, so I ran the benchmark multiple times with varying data sizes to get a better idea of how the library performed under different circumstances, larger and smaller HTML templates, or really larger and smaller amounts of data that we're filling the template out with. So just some terms, you probably know this, but I wanted to call that out again and show just like how small these numbers are. So we got millisecond, which is like 1,000th of a second here, 0.001 seconds. And then we've also got microseconds that we're working with, which is 1/1,000,000th of a second. So 0.0000001 seconds. And so when we get to the 10 items, this is basically what benchmark.net outputs. So you can see that Replic's running some sort of Ubuntu 20 in here. It's got some sort of Intel chip, 1 CPU, 8 logical and 4 physical cores, and yeah, just like a small little machine in the cloud. That's one thing I like about Replit is you can kind of just expect it to use the same or similar machine as well. So some of these benchmarks theoretically are a little bit more standardized. Okay, so all the details are here, but I've also kind of brought out the highlights here. So we see that, cached is faster by about 30% or 0.05 milliseconds, but the cache parser, it's doing this in about 0.1 milliseconds or about 100 nanoseconds. So this is like incredibly fast. And the raw parser is slower at 0.17, 0.2 milliseconds, but like this is so small that it's basically unnoticeable. So cache parser is significantly faster, but the absolute difference is about 0.05 milliseconds, which is essentially unnoticeable. For small templates, Scriban is quite fast and way faster than I expected, to be honest. Now let's go into 100 items. So here we see that cache parser is running in about 0.4 milliseconds, and then the raw parser is running in about 0.5 milliseconds. So here again, cache is faster by about 20%, but the difference is like very small, right? It's only 0.1 milliseconds. So here cache is still has an edge of about 20%, but at 0.1 milliseconds, it's still essentially unnoticeable. Interestingly, it seems that the work is scaling sublinearly. We required 10 times more data population, but only needed about 4 times more time to do so. So at 500 items, the cache parser is taking about 3 milliseconds, and then the raw parser is taking taking 2.8. So in this case, it's interesting. The raw parser is, again, actually faster here by 7%, but we're still at that 0.2 milliseconds. So by now we can kind of see this pattern that like probably the parsing only takes about 0.1 to 0.2 milliseconds, and all the extra time we're seeing is really the rendering. And so this starts to give us like some idea that probably the parsing of each one is this 0.1, 0.2 milliseconds. And so if you want to save that, that's when you might want to cache. But if you don't care about it, and like this probably doesn't matter in most cases, then it probably doesn't matter. So here we start to push Scriban a bit. It's unlikely that you want to actually render 500 items in a list like this, but I think this starts to show us what it's like if we have a more complex template populating lots of different data, totaling a few hundred fields. And this is probably what you're going to be doing, right? Like you're probably not just going to have like one big template, although you might, but we're kind of in the land of like React components and stuff. So even if you're doing server-side rendering, you're probably going to think that way. And so what you'll probably end up doing, and kind of the way that I'm thinking about this, is you'll probably have like maybe one external template, and then you're going to have a bunch of different components for like the main page, the header, the footer, the, I don't know, whatever interactive thing you got on the sidebar. And each of those is going to incur this cost of parsing and rendering. And so one item won't have like 500 items in it, or one component probably won't have 500 items in it. Let's say it has like 50 for like a big component, but together, with your 4 or 5 different components on the page, you might have in the low hundreds of things. But still, Scriban is handling this quite well with a mean of around 3 milliseconds, which is, again, unnoticeable to a human, though perhaps noticeable to our systems, and with the raw cached parsers, just 0.2 milliseconds different. And so again, I want to benchmark against like what is JS normally doing, but typically if you can get your page to render in like 100 milliseconds or less, it's going to feel snappy to humans, and that's kind of like the bar we want. When we're dealing with systems, we do want to be a little bit faster, because like this is it's never going to be the only thing going on in your system, and so you want to leave like quite a lot of headroom for when the system's running slowly, or maybe again you have like these really deeply nested components, and so these kinds of 3 milliseconds here, 3 milliseconds there, times 20 if it's super deeply nested actually adds up, but still like very, very fast. And I would argue that probably raw being faster here is just kind of a fluke, because it's pretty easy for these 0.2 milliseconds to happen, maybe because replit machine is being slow, or like, I don't know, a few of the cache parsers got like hung up on something. So I would more say that like the 0.2 milliseconds thing isn't that significant. Okay, moving on. So then we try 800 items. So mean is again 5.1 milliseconds for cache parser. The raw parser we're getting 5.3, so the difference is about 0.2 milliseconds. And again, the rendering is really taking over most of the work, so the parsing difference is really around to like about 4% here. So here we reach the extremes of what Scriban is built for. Seriously, at 1,000 items, we broke it. Yet it still performs remarkably well with around 5 millisecond renders for a truly unreasonable amount of data being displayed on screen. Even at this juncture, the difference between raw and cached parsing remains small at a 0.2 milliseconds, giving us confidence that both are generally fine approaches with little to no performance difference between them. And yeah, I really think that this is the takeaway here, is that you can use either one in most scenarios and be totally fine. If you're not doing some like super high computing stuff, then this probably doesn't matter. And if you're trying to render HTML, that's like not a good way to pass data around, so like you probably aren't. So probably this 0.2 milliseconds here just doesn't matter. And so I thought this was interesting. I actually started like, let me try 10 items, 100 items, 1,000 items to see what happened, but the 1,000 items actually broke, and so that's why I went down to like the lower hundreds. And I thought this was interesting, so we'll just talk about it real fast. So failed to run, and it seems that we pushed Scriban to its limits. It seems we got blocked by a system.reflection.target invocation exception, presumably for doing too many iterations as part of this process. And if you look at this exception message, it's saying, hey, error, you're exceeding the number of iteration limits of 1,000 for this loop statement. And so it seems internally Scriban's doing some sort of reflection. So my guess is this limit is here because reflection is generally slow and expensive, and it, as in .NET, wants you to prevent you from crashing yourself accidentally. My other guess is that we could probably lift this limit with some configuration, but I think 1,000 items is mostly unnecessary for UI renders, and thus it's okay that this break for our purposes. So I do think you should be aware of this, but like I don't think anyone in their right mind is trying to like render 1,000 items to like a HTML template or something, so you probably don't care about this. And I will say that this shouldn't apply for like, again, that nested scenario where like in total you have 1,000 items. That should be fine. It's only, I think, when you have like 1,000 items in one single component and one of these loops. I haven't tested this, of course, but I think that's a pretty reasonable guess. Okay, now we can get into the full benchmark code. Let me just open up Replit here and show you. So this is just using the raw F# replit, like, I don't even know what they call it, like template thingy. And I just got benchmark.net and Scriban in here. And let me just start running this as well, so that as we talk, this can give us some data. So I'm running this in release mode for benchmark.net, and then I'll just make this bigger so you can see it. And so this is all in just main.fs, which if you're in another language, that's just like your main. And we put all our types at the top because we'll use it later. So the first thing is just our template props. Again, this is just a string or a list of strings, which I'm calling items here. And then we're creating a type called Scriban benchmarks. Normally I try to just like do this all functionally, but you know, when we're interacting with C# libraries, C# is very OOP, and benchmark.net follows that style. So we need a type to actually run this stuff, but you know, F# still targets .net, so this actually plays very nicely with these C# things. You just kind of have to, you know, get it in the right style. So here we have our item count 800. This is how we know we're running out on 800 items, and then we're just creating our test items. And so what we're doing is we're just creating a big list of GUIDs, which are just randomized strings, and then we're getting a list of them. So we're materializing them before we do our benchmark. Here we have the test template that I was talking to you about, and then here's where we create our cached parser and our raw parser. If you wanted to learn more about why we're using member renamer, you can look here, but basically it's so that Scriban doesn't change this. We can access it like items versus it's trying to use like some snake case, lowercase stuff, which we don't want. And then this is the only other thing we have to do. So I already showed you how we created these here. So the instances of the functions that we're going to call. And now we just have to wrap this in benchmark for benchmark.net to run. And so we can see that run cache parser is calling our cache parser here with the items, and then run raw parser is doing the same thing with the test item. And then we got our main, which is pretty simple. It prints this out to start just so we know that it's running. And then it's going to actually run the benchmark. And the benchmark does a lot of work and outputs all this stuff, which is how we get those pretty summaries at the end. So we'll just wait to show you what the summary looks like at the end. And here it is. So this time for 800 items, we're getting out about 4.5 for cached and 4.5 for raw. So I'm pleasantly surprised with how easy and performant HTML template parsing has been in F#.net, and especially with Scriban. I think, you know, again, with Razor Engine or something, this probably would have been painful. But with Scriban, you can kind of do it very functionally. You just pull in the thing and you just use it, which is great. I'll likely continue experimenting and try using it for more of my projects. Yeah, let me know if you're interested in this kind of server-side rendering template things. I think I'm going to explore this, HTMX, and see how far we can kind of get without a dedicated front end. So let me know if you're interested in that. And then if you like this post, you might also like some of these. So for benchmarking, you might be into F# versus TypeScript performance, where we sort a million elements and see which one's faster and by how much. If you're into F# and building web APIs, you can check out this one, which is a short tutorial on building a simple F# web API with Giraffe. And then if you're new to F# and just curious about like the language and its future, I have the State of F# 2023 diving into all this stuff, where it is now, how it fits into the ecosystems, where it's probably going to go in the next few years. So check that out. That's it for this video. Thanks for watching, and I'll see you in the next one.